in case if you are a student who want to know the why behind a particular concept, in case if you are a student who wants to learn the gold standard content, who wants to learn from the author of 9 mathematical books, this class is a must attend for you. At the end of the class, you are going to learn a lot of concepts related to how to find the approximate value. How to find the approximate value. How to find the approximate value for square root of 29, square root of 5829, cubed root of 13, cubed root of 121, fifth root of 7292624. How to find out the approximate values for a non-perfect squares, non-perfect cubes, and non-perfect fifth powers with complete proof behind the concept. At the end of the class, you will be able to explain the reason behind why that concept is used. Why that concept is used. Probably for the first time, if you check these logics in anywhere in YouTube channel all over the world, you might not get the proof behind the concept. Now we are going to discuss the proof behind the concept, because if I firmly believe in explaining the why behind the concept rather than just solving a mindless problem solving. Very, very interesting class, very, very exciting class. In case if you enjoy this concept, kindly like and subscribe to RYP channel and ANIL NAIR classes channel, and share this class with every teacher who has given this video without giving you the proof behind that video. I firmly believe that generally many of them teachers students to remember the formulae. I teach the logic behind the formulae. Many of them tells you to cram the information. My classes are to acquire the knowledge. They tell everything which probably results in a short-term memory. I emphasize on understanding the concept and appreciating the concept. Many of them says that textbooks are the end points. I say that from the textbook you can take the concept to the next level. How to find the approximate value of a cubed root of 1337. How to find out the cubed root of a 13724. And how the cubed root is determined. How to check whether a number is a perfect cube or a non-perfect cube. How to check whether a number is a fifth power or a non-fifth power. Let us straight away get into the concept. Very, very interesting concept. Very, very exciting concept. Let us see the concept first. Concept. Key point number 1. One by one we will discuss the key points. Key point number 1. Key point number 1. A perfect square. A perfect squares always will be of the form. Always will be of the form 4 into something or 4 into something plus 1. Any perfect square will always be of the form 4 into something or 4 into something plus 1. Why? We have already discussed in our perfect squares class. A perfect square will always be of the form 4k or 4k plus 1. Second concept. A perfect square never ends with. A perfect square never ends with 2, 3, 7 or 8. This is the second property of a perfect square. These also we discussed. Third property. What is the third property? Every perfect square. Digital sum will be 1, 4, 7 or 9. Every perfect square digital sum will be 1, 4, 7 or 9. 1, 4, 7 or 9. For a number to check whether a number is a perfect square or not, first check whether it is of the form 4k or 4k plus 1. A perfect square never ends with 2, 3, 7 or 8. Every perfect square digital sum will be 1, 4, 7 or 9. For example, Root of 29 it is there. Root of 29. Root of 29. 9 plus 2, 11. 11 is 1 plus 1, 2. Every perfect square digital sum should be 1, 4, 7 or 9. 1, 4, 7 or 9. So it is a non-perfect square. This is a non-perfect square. Then non-perfect square. Non-perfect square. Suppose if it is 154, it is there. 154. Square root of 154. A perfect square will always be of the form 4k or 4k plus 1. 54. 4 into 13, 52 plus 2. A perfect square will never be of the form 4k plus 2 or 4k plus 3. Again it is a non-perfect square. Again it is a non-perfect square. A non-perfect square. A non-perfect squares always gives an approximate values. A non-perfect squares always gives an approximate values. How to find the approximate value of a non-perfect square? Square root of 29. 2 plus 9 is 11. 1 plus 1, it is 2. If the number is a perfect square, it should have digital sum 1, 4, 7 or 9. This digital sum is 2. This digital sum is 1, but it is not of the form 4k or 4k plus 1. These are the three tests that we need to conduct to check whether a number is a perfect square or not. I hope it is clear. First point, write down in your notebook. First point, write down in your notebook. First point. These are some important key points. At the end of the class, you will not get a single doubt. That means if root n it is there, n is a perfect square. N it is a perfect square. N it is a perfect square. I will get an integer. I will get an integer, positive integer, which is nothing but a natural number. Square root of positive number is always a natural number. If n is a non-perfect square, if n is a non-perfect square, if n is a non-perfect square, I will get a decimal value, and which is an approximated value. Approximated decimal value. Approximated value. If n is a non-perfect square, I will get an approximate value. If n is a perfect square, I will get a positive integer, or it is a natural number. This is something which you will find it in all the textbook. Now we will see how to find out the approximate value of a non-perfect square. How to find the approximate value of a non-perfect square. Very interesting logic. Watch till the end of the class. Then you will understand the beauty of thematic based learning. You will understand the beauty of thematic based learning. Approximate value. Approximate value of a non-perfect square. Approximate value of a non-perfect square. Approximate value of a non-perfect squares. I will teach you multiple methods. Approximate value of a non-perfect squares. First one, square root of 29. Square root of 29. Multiple methods with the proofs. Method 1. This is not anybody's method. This is proposed by a famous mathematician by name Trachtenberg. Trachtenberg. Trachtenberg's method. Trachtenberg's method. Square root of 21. How to find out the approximate value of a non-perfect square. A non-perfect square will never give an natural number at the end. How to check whether a number is a perfect square or not? All that we discussed. Trachtenberg says square root of 29. Root of 29 lies between which two squares? One is the square root of 25. Another is square root of 36. Square root of 25 and square root of 36. Root of 25, it is 5 plus. 29, 25, difference is 4. 36, 25, difference is 11. So answer is 5, 4 by 11 approximately. 5, 4 by 11 approximately. From Where this concept came, limit h tends to 0, f of x plus h minus f of x by h. From these limits, he has given these proof. You can actually download Trachtenberg's book of speed mathematics, then you will get this approach. What he did, square root of 29 lies between which two squares? Root of 25 and root of 36. 5 plus 4 by 11. 4 by 11 is approximately 0.36, so it is 11 3s are 33, 70. Close to 5.36. This one method. I am not interested in a foreigner's way of solving. Ramanujam has proposed another interesting way to solve a problem that we will see. One more example. Square root of 137. Square root of 137. A perfect square never ends with 237 or 8. A perfect square never ends with 237 or 8. It lies between 11 square is 121, 12 square is 144. 11 plus 137, 121, 16. 144, 121, 23. Approximately it is 11, 16. The source for this book is Trachtenberg Book of Speed Calculation. Trachtenberg Book of Speed Calculations. Trachtenberg Book of Speed Calculations. You will easily get these PDF in Google from that concept which we are discussing. I am not interested in this method. I will tell you another alternative method proposed by a famous mathematician coming from India. That is my inspiration, Ramanujam's. Method number 2, we will discuss Ramanujam's method of finding the approximate value of a non-perfect square. It is good to know this method. Square root of 29 lies between which two perfect squares? Root 25 and root 36. Root 29 is anyway greater than root 25. 5 plus 29, 25. Difference is 4. 36, 25. Difference is 11. So answer is approximately 5, 4 by 11. This is nothing but 11, 16 by 23. I hope this method is clear, but my entire attention is on Ramanujam's method. Ramanujam's method, everyone should know this method, and he is one of the prodigy in the field of mathematics. Ramanujam's method. Method number 2. Very, very important method. That is what I was telling my friend. Unless you know the proof, how come you are teaching a concept? Are the students not asking you the reason behind why it is happening? Ramanujam's method. Now Ramanujam's method is square root of 29. Square root of 29. Root of 29. It is just greater than nearest perfect square. Root 25, it is 5. Root 25, it is 5. 5 plus 29, 25. What is the difference? 4. Double this value. 10. So both are approximated values. Trachtenberg method has given us 5, 4 by 11. Ramanujam's method will give you 5, 4 by 10. Don't do this mistake of, this is what I used to do it in school days. 5 1s are 5 2s are 2 1s are 2 2s are. That is a stupid way of understanding mathematics. It will happen if you got a bad teachers in your life. I hope it is clear. Don't do all this. 5 4 by 10. 5 4 by 10, it is nothing but 5 4 by 10. 5 4 by 10 is 5 2 by 5. It is approximately 5.4. 5.4. 54 whole square is 2916. 5.4 whole square is 29.16. 29.1 is very, very close to 29. So square root of 29, this is the value. I said, did you discuss it the students how these 4 by 10 you got? You are telling it vaguely. 29 minus 25, it is 4, and double this value. This is where some smart students will ask you a doubt, and smart students knows that you are just telling it from a textbook without giving you the proof. If you see any kind of YouTube videos where they are teaching you like this without giving you the proof, you can understand the level of subject knowledge they got it. One more example, square root of 43, square root of 43. You can do this one either by taking a perfect square just less than 43 or a perfect square greater than 43. Root 36, it is 6. 6 plus 43, 36, it is 7. Double this value. So it is closer to 6, 7 by 12. It is closer to 6, 7 by 12. Hey Anil sir, can I take root 49, which is nothing but 7? Root 43 is less than root 49, so minus. Difference is 6. So this is nothing but 7 minus 3 by 7. 46 by 7. 6 6 are 7 6 are 42. 6 4 by 7. 6 4 by 7. So 6.5 whole square is 42.25. Either you can take a perfect square just less than root 43, or you can take a perfect square just greater than root 43. I hope this method is clear. The entire class is developing an approach which makes you to solve the questions for a non-perfect square, non-perfect cube, and so on. I am not interested in telling this model. I am interested in teaching a concept which will help you to solve any powers beyond non-perfect squares. Here, why I discussed this? Sir, can I take a perfect square less than root 43? Yes. Root 36, it is 6. 43, 36, it is 7. Double this number. Root 43 is less than root 49, 7 minus. 43 is less than 49, so minus. Difference is 6. Double this number. Why are we doubling this number? Why are we taking a difference? The entire class is about telling you from where you got this point. From where you got this point. Now, listen carefully to the next explanation. Anil Nair's proof. Why that came into picture? Why that came into picture? Very, very interesting and an exciting way of looking at aptitude through a prism never seen before. Anil Nair's proof. Now listen carefully. Suppose root A, I need to find out root A. What is A here? A is nothing but a non-perfect square. A is nothing but a non-perfect square. A is nothing but a non-perfect square. I want to find out the approximate value of a non-perfect square. Listen carefully, sir. For example, A is 29, A is 31, A is 54, A is, for example, 235. All these are perfect squares. All these are perfect squares. Can I say root 29 is greater than root 25? Am I right? Or it is equivalent to, or it is greater than root 25. Can I write? Root 31, it is greater than root 25. Yes or no? Root 54, it is greater than root 49. Are you all with me? Root of 235, it is greater than root of 225. Are you all with me? Am I right? Now listen carefully to this concept. Can I say 29 is nothing but 25 plus something? Yes or no? 31 is nothing but 25 plus something. 54 is 49 plus something. 235 is 225 plus something. 225 plus something. Let this A is nothing but I plus E whole square. I plus E whole square. What is I plus E? I is nothing but a nearest integer. E is nothing but an estimated approximation. E is nothing but an estimated approximation. E is nothing but an estimated approximation. Like a previous example, 29 is 25 plus something. That something value we are trying to find out. 31 is 25 plus something. Something value we are finding it out. Root 29 is greater than root 25. Answer will be 5 point something. What is that something we are trying to find out? Root of 103 is greater than root 100. It is answer is 10 point something. What is that something we are trying to find out? What is E here? E is nothing but an estimated approximation. E is nothing but an estimated approximation. So A is nothing but I square plus 2 into I into E plus E square is E square. A plus B whole square is A square plus 2AB plus B square. I hope the concept is clear. I square plus 2 into I into E. I is the nearest integer. I is the nearest integer. I is the nearest integer. Now see here. A is 29. I is 5. 5 square plus something. That means, can I say estimated value is a very smaller value? Do you agree? Estimated approximation value. It is nothing but a smaller value. Anyway, it cannot be 1. 5 plus 1 is 6. 6 square is 36. E is very, very small. E is very, very small than I. E is nothing but dot something. Root 103 is 10 point something. That something after dot, it is nothing but E. Root of 154 is 12 point something. What is that something after dot we are finding? It is a very smaller value. It is a very negligibly smaller value. A minus I square equivalent to 2 into I into I. E. Approximated to, because it's a very smaller value, point something whole square. This value addition, it will make a very, very nominal difference. That means E is nothing but A minus I square divided by 2 into I. A minus I square divided by 2 into I. I hope the concept is clear. E is nothing but an estimated value, which is a very smaller value. I square plus 2 into I into E plus E square. It's a very smaller value. Anyway, I am finding the approximate value. So I can eliminate E square. I can eliminate E square because E square is a very smaller value. A minus I square is 2 into I into E. E is nothing but, again I am writing, A is nothing but I plus E whole square. Once you understand, you can also teach the teachers. I square plus 2 into I into E plus E square. E is an estimated approximated value. E is an estimated approximated change. E is an estimated approximated change. So this is a very smaller value. So A will be extremely close to I square plus 2 into I into E. I square plus 2 into I into E. So this I is nothing, E is nothing but A minus I square divided by 2 into I. Now the concept will be extremely clear to you. Now the concept will be extremely clear to you. Now I want to find out root of A. That means it is root of I plus E whole square. Square under root cancel. It is nothing but I plus E. E is nothing but A minus I square divided by 2 into I. Finish. It is nothing but root A approximate value. It is nothing but I plus A minus I square divided by 2 into E. I hope the idea it is